Okay, let's get going on this one here. This is video number 35. I'm pointing out, using a calculator, the important difference between rational and irrational numbers. And why are we talking so much about irrational numbers? Well, not only is pi a rational number, anytime you put the radical sign, or what I sometimes call the hat, over a number that's not a perfect square, different things are going to happen. What I'm trying to say is that the nature of 1 over 7 and radical 2 are profoundly different. And I hope to show you how that works today. By the way, when I choose 1 over 7, I'm just choosing a number with a long repeating decimal. Let's go over some stuff we learned in elementary school in 6th grade. Terminating decimals, 1/2 equals 0.5. What they really mean is 0 goes on forever. 3 over 4 is 0.75, and we're just saying that the 0 goes on forever. Some easy ones we did in when we did scientific notation, 2/3. We always wrote 0.6 bar because we said the bar just indicates that the 6 goes on forever. If I need to round, it's the same old story. I go to the next guy, say to the 100th, circle the 6 and round it. And this is typically what we see when we're rounding. 6th grade math, elementary school math. We know how to do that. I chose 1 over 7 because that's a longer repeating decimals. Anytime you divide one integer by another, you're going to get repeating decimals. In this particular case, we say the period is 1, 2, 3, 4, 5, 6. So we call it period 6. Don't panic, I won't be teaching this stuff. It has to do more with number theory than anything else. But the point is that no matter what two numbers I choose, you're going to get a repeating decimal of some sort. When I choose 1 over 7, 1 over 13, 1 over 19, 1 over 29, these prime numbers, the period gets much, much longer. Keep that in mind. But we're just here to make the basic point. So a rational is any number divided by another number. You might say, but isn't 2 a rational number? But the way a mathematician looks at it, 2 is really 2 divided by 1. Or any number or integer you can think of, okay? So let's take a look at what's going on here. The point is, what's the profound difference? What's the main issue here, the difference that we can see when we do the math? So I'll erase this here, and you might say, well, wait a minute, man. It's 1, 4, 2, 8, 5, 7, 1, 4, 3. What happened? The calculator fell out of space, that's all. It doesn't have any more space to work. The real number just keeps going on forever. There we go. We often draw the line above it to indicate the period of going on the decimal. But that means we can round to any number we want. So let's do something absurd almost. I want to round to 1 trillion. Oh my God. What would you want to do that for? To 1 trillion. Somebody, some crazy person wants to round to 1 trillion. Well, the calculator ran out of space right here, which is going to be 1 billionth. We'll show you that in a second. So it rounded and turned it into a 3. That's an easy explanation that most 8th graders can understand. So my object here is to round 1/7 to 1 trillion, and then to attempt the same with this new kind of number, which we're calling a radical number, irrational. So let's go and do the work now. Let's see, we got 1/10, we got 100th, we got 1,000th. You learned all this in scientific notation. 10,000th, 100,000th, 1,000,000th, 10 millionth, 100 millionth, billionth. You see your calculator goes out to 1 billionth, 10 billionth, 100 billionth, 1 trillionth. I get it. It wasn't that hard, right? Circle the next number, draw the arrow, and that's what your calculator would say. So it doesn't matter how small. The smallest number I can imagine in my brain is easily rounded 1 over 7, or any two numbers that I choose. But that doesn't work with this guy. Let's try it again. 10, hundredth, thousandth, 10,000th, 100,000th, millionth, 10 millionth, 100 millionth, billionth. I'm stuck, brothers and sisters. Without a computer or a bigger machine, there is no way I can figure out how to round this guy. We would say impossible without more data. That is, without either a computer, because there are math programs that can go on forever. Obviously, they figured out how to go do this guy. But the basic point is there's no pattern. There's no way to predict what comes after the 2. In fact, if you're a betting man, you might have an over, 5 or bigger, or an under, 4 or less, and you could just flip a coin. It's 50-50 what it's going to be as far as we know. Okay? So there you go. An interesting idea, a feather you should place in your cap when someone starts talking about rational and irrational numbers. They're profoundly different. They have different aspects to them. And you should be aware of that going ahead and doing your math. So when I start teaching you today a lesson on the on radicals and how they add and how they subtract, these are profoundly different beasts in the zoo than are the rational numbers, which we are just dividing one over the other. I always know how to round to any number I can imagine. With this guy, I need help if I want to know what comes after the 2, how to round the 2. Thanks to the calculator, I could round it to 100 million, and that would be the answer. It would end in a 6. But beyond that, the nature of the number itself prohibits you from going on to the next one. And I hope that makes sense to a lot of kids who've been listening to this video. All right, I'm going to leave it there. Keep in mind what I just said.